Okay, so we're gonna do acid catalyzed Fischer esterification. Basically, we're just gonna take a carboxylic acid and we're gonna turn it into an ester. So whatever you see right here, however long this is, we're just gonna add it right here and get rid of the H. That's really it. Okay, so to start off with this, we have a weak base. And so since we have H2SO4 in heat, it's just gonna protonate it. So you could just add an extra H here. So he's being protonated. So we're under acidic conditions, so we're only gonna have positive charge. You're never gonna see a negative charge in this mechanism. So it's gonna go. Lone pair is gonna attack the hydrogen, and then right here we're gonna have our first acid base. So right here, he's gonna have too many charges. So we're gonna make three resonance structures to find to see which is the minor, because we're gonna attack the minor. So we'll just push that arrow right there. And now, no, we'd push it here. If he has two H's, this would, wait, yeah, this would go here. So then he would be good. But then now he would, whoa. I messed up right here. Is how it would look, and he would have too many charges. And now, this would push here. So then he would now, the carbon will now have the positive charge. And if you want to make a third one, like imagine this lone pair pushed here. So now he would have the positive charge. So now we're gonna look for. So now we're gonna look for basically the minor resonance structure is gonna be the one that is the worst or the second best. So carbon, whatever has whichever one doesn't have the octet. So carbon right here doesn't have an octet. It says 3, so it's the minor. So we're gonna attack it with right here. So this should actually be more here, right here. It's on the carbon. So our thing is gonna attack it right here. So once he attacks it, we could add it right here. He's gonna have too many charges. He's gonna have an extra thing, so we're gonna end up repronating him. So we'll just take it again right here. The same guy, the normal guy. I don't know the difference honestly, but we're just gonna depronate him, make him normal. So now we're gonna get right here. We're gonna get this right here. So our goal in this mechanism is to make an ester. So which one are we gonna? So right here we're in like a neutral state. So right now we're gonna want to get rid of one of these OHs, right? And right now both of them are bad leaving groups. OH is never a good leaving group, so we're gonna have to turn it into water so it can leave. So since we have since right here we just take an H, we could make whatever we made there, we just put it right here. So he's gonna have a plus charge, or one of the oxygen, doesn't really matter. One of the alcohols is gonna just take the H. And so now this has too many bonds. So now it's gonna now it's out. Now it's water, right? So it can leave on its own. So this is where we formed water. I think this is where the water came from in the thing. So we're forming water. So right here. I'm not sure if this is the neutral. This is the neutral tetrahedral intermediate. So we could just put like right here. It's neutral tetrahedral. Tetra intermediate. Okay, that's the neutral one. So yeah. So it leaves, and so if it leaves, carbon is now gonna have a positive charge. So once you see like positive charges, that should be a like a indication that now we can make some resonance structures. So now we're gonna make a resonance structure, push a bond there. Now he's good. Wait, no, he wouldn't be good. He would have the positive charge. And you know, and then if you want to make another one, we just want to get the we basically want to just be able to deprotonate this alcohol. So I know in the last example we didn't the last example we went for the second best resonance structure. So I can understand why it's confusing. Like, why are we gonna? Which one are we gonna attack now? But in the goal is right. We're gonna want to get this by itself, right? We want to have this oxygen by itself. So we're gonna want to deprotonate that, so we can make a carbox. We can make the ester. Okay, so who's gonna deprotonate it, right? Who's gonna take, like, let's if you were to specify, like, who is gonna take this H? Who's gonna take it? Okay. So how are we gonna it's more about, so what did we form right here? Okay, it's gonna be, honestly, I think forget about the water. Whatever we have right here, it's gonna take that H. Okay, so if we just if this oxygen attacks right here, push that onto the oxygen. Now we're gonna form this structure, and we should be good. Yeah, I think this is the end of the. I think I added a bond right there, but yeah, we should be good right here, right? And then we're gonna have to like regenerate the base catalyst, right? This is the base catalyst. This right here, we're gonna regenerate it. So whatever, I'm talking like I don't even know why I'm using all these big ass words. It's just I don't even know what I'm saying. Also, just show it. Like you depronated it. Just just show it again. Okay, that's really it. I mean, even like specify my teacher like base catalysts regenerated. Okay, that's how you make see, this is the answer we got. This is how you make it, honestly. And if you want to show your water, whatever. All right, this is how you do it.